Hey guys, so in today's video we are starting a new unit on similar polygons. All right, so that is going to be the topic for the next couple of weeks here. And what I want to talk about today is the difference between congruent versus similar. All right, so problems that we're going to look at today look like this. You'll have a pre-image and an image. They'll almost look identical, but there's a couple things that we want to talk about today: a similarity statement, and a couple of others as we go through these definitions here at the beginning. So what are similar polygons? Let's begin there. Similar polygons, when you dilate polygons, similar polygons are created. Remember, we just finished talking about dilations. Dilations is when you take a pre-image and you either enlarge it, you make it bigger, or you reduce it, right? You make it smaller. So if we take a look at the example that I have over here on the right, if you can imagine that one being the pre-image, A, B, C, D, going to our image W, X, Y, Z, it looks like an enlargement, and you would be correct. It got significantly bigger. So again, whenever we dilate any polygon, any shape, whenever we dilate it, we are creating a similar polygon, right? It's not identical. It's not copy and paste. But again, it's similar in a couple of things here. Same shape, but different size. This is kind of the important thing here. Similar polygons, they are the exact same shape, right? It's not like that polygon turned into a star or something else. It's the exact same shape, but it has a different size. It's either bigger or smaller, whether that was an enlargement or reduction. Okay, here's a couple of other key pieces. Corresponding, let's see if I can find a different color that stands out. Corresponding angles are congruent. What we mean by that is even though we enlarged it, take a look. Angle A, even though we enlarged it, angle W would still be the same thing, right? If this was, let's say, 30 degrees, angle W, just because I enlarged it, right, just because I enlarged the sides, the angles still stay the same. That would still be 30 degrees. Same thing for the other ones, right? We'll take a look at B. If B, let's say B was 40 degrees, what would X be here? Its corresponding angle would also be 40 degrees. Just because we enlarged it, our angles are still going to stay the same. But that's not the case for the sides. Take a look at the sides here. Let me see if I can find a different color. All sides are equally scaled. What we mean by that, right, when we are enlarging it, we have to keep the same shape. So we got to make sure that when we're applying that scale factor, we were applying it to all of our sides. Take a look. How did I go from 5 to 15? That looks like a scale factor of multiplying by 3, right? How do we go from 5 to 15? We multiplied by 3. Well, it's the same thing for all your other sides. They're equally scaled by that scale factor of 3. How do I go from 3 to 9? I multiplied by 3. How do I go from 2 to 6? Multiplied by 3. How do I go from 4 to 12? I multiplied by 3. Okay, so again, all the sides are equally scaled. All the angles are congruent. So again, this is what we mean by similar, right? It's not a copy and paste. It's a smaller or bigger image from what we started with. So whenever we have similar polygons, we like to write similar statements. These similarity statements. This little symbol in here, this little squiggly, that is what we call similar. It is not congruent. Please be careful not to confuse it with congruent. Congruent is when it has that little squiggly with an equal sign. That means congruent. When we just have the little squiggly, it means similar, right? It's not a copy and paste, but they do have some characteristics in common, all right? They do have some characteristics here in common. So take a look. The order does matter, all right? What I mean by that, the order does matter here. A, right, if you take a look at angle A, remember that is corresponding still to angle W, okay? So again, the order does matter, right? Even if you're taking a look at the sides, if you're trying to compare sides, let me change colors here. If we're talking about from C to D, take a look from C to D, okay? That is going to correspond to Y and Z. So from Y to Z. Okay, so those are going to again be related. C to D is similar to Y and Z. Okay, there it's obviously scaled here, but again, that is its matching side. And it was scaled by a scale factor of 3. I should include that as well. All right, so again, whenever we write a similarity statement or whenever you see a similarity statement, it's basically letting you know what is matching up, what angles are corresponding to which angles, what sides are similar to what other sides. So proportions. A proportion, guys, is an equation that states one fraction is equal to another. So for example here, 1 over 2 is the same thing, is equal to saying something like 5 over 10. So that is a proportion. It's when you set two fractions that are equal to each other. Similar sides of similar polygons are proportional. As we were talking about sides of polygons, they are proportional. The last example, everything was all these sides, 5, 4, 2, and 3. All of those sides were being scaled by a factor of 3, so they are proportional. So set pairs of corresponding sides equal to each other, and again, the order does matter. So here we have a proportion, which is going to help us solve a couple of problems eventually as we progress. So let me explain what this statement here is saying, and I'll try to match those colors and go back and forth. So here it's saying that AB, so in the first triangle, from A to B, that measured 12. Okay, and so we're comparing it, AB, we're comparing it above PQ. Take a look, it's the exact same left side, but now it's for the image, right? So that's 12 over 6. Let's keep going with this statement. Take a look at this proportion. Let me keep going here in red. Take a look at from B to C. From B all the way to C, the bottom side of the first one, 8. We're going to compare it to Q to R, the bottom one of the second triangle, which is 4. All right, we have one more thing, or one more set of sides to compare here. Let me go back to green. So here we're looking at C to A. So from C all the way over here to A, that used to be 18, right? And if you take a look at the new one now, from R to P, now that is 9. Right? So this proportion right here is telling me that if these guys are similar, if I actually go through and I simplify all of these, if I go through and simplify, what color can I use to simplify? I'll use orange here. What can I divide 12 and 6 by? I can divide that by 6, and I can simplify the bottom by 6. 12 divided by 6 is 2. 6 divided by 6 is 1. That's equal to, take a look at the fraction 8 over 4. Actually, I could have gone through and divide. Let me actually show it that way. Let me actually divide. What is what's 12 divided by 6? That's 2. That's equal to, what's 8 divided by 4? That's 2. What's 18 divided by 9? That is equal to 2. So take a look. That is how you can prove that these triangles are similar. All of their sides have that same, all those sides are proportional. They were all scaled by the same scale factor, right? Which in this case was 2. All right, let's take a look at our first example. So example number 1 says name all pairs of corresponding sides and angles. So let's start right there, and then we'll answer the second part that says prove that the figures are similar using a proportionality statement. So I'll explain that here in a second. But let's go through and name all the pairs of corresponding sides. Okay, let's work with sides. So we're going to focus here on these 3 sides. So I actually don't even need to look at the triangles, and don't just rely on looking at the actual picture. If they ever give you a similarity statement, guys, refer to that. You should not even be focusing on the picture. We're going to go through and match these corresponding sides by using that statement there, that similarity statement. So from L to M, so using the first two here, from L to M, right, it should be the same as R and S. From L to M, it should be the same thing from R to S. Okay, so I'm going to write R to S. All right, let's keep it going. What about from M to N? So from M to N using the last 2 letters. Well, that's going to be from S to T. Those are the sides that match up, from S to T. And don't forget to use that little symbol up top that says it's a line segment, right? It's a part of a line. And then our last side here, from N to L. From N to L, if I use my statement here, from N, the last letter and the first letter, we're going to use the last letter and the first letter of that second part of that similarity statement. So from T to R, T to R. So again, that's just going through, guys, and matching up the appropriate sides, right? That's going through and just matching the appropriate sides. We want to do the same thing now, but we're going to do it with the angles. So I'm going to do the same thing here, but I'm going to do it with the angles. Let me use purple for the angles. And again, look back at that similarity statement. So if we're looking at angle L for this first one, so let's take a look at the angles. Which ones are corresponding angles? So if I take a look at L, that's the first letter. I want to compare it to R, angle R. Okay, angle L is congruent to angle R. Move on to the next one, M. M is the middle letter, so it's going to be the same thing as S. Angle M is congruent to angle S. And then the last thing is angle N. The last letter here is the same as that last letter there, which is angle T. Those are congruent angles. So that is it. That is how you name all the pairs of corresponding sides and corresponding angles. Just going through and matching. This is literally a matching game, right? And again, please, please, please make sure that you're referring to, don't just eyeball it and say, oh, that side looks similar to this side. No, look back at that similarity statement. So how do we answer the second part of this problem? The second part of this problem says, prove that the figures are similar using a proportionality statement. So it told me that they were similar. Now I actually have to make sure that I prove that. The way we're going to prove that is by creating this statement here, going through and matching our corresponding sides. Okay, so let's go through and match up those corresponding sides. Let's create that statement here. So take a look. LM. Well, LM, if I look at my triangle here from L to M, that was 9. I'm going to compare that to RS. So where's RS? So that's 9 over 6. Okay, let's keep going through and matching it up. Now let's take a look at from M. Let me erase a couple of things. From M to N, that was 12. We're going to match it to from S to T, which is 8. Right, it's just a matching game. It's just a matching game. We have one more side we have to match up. That is from NL, from N to L, which is 15. We're matching that to TR, from T to R here, which is 10. Okay. So that is our proportionality statement, but it's still, I still have to go through and actually simplify and prove that all three of these fractions are actually equal to each other. So let's go through and simplify them, right? And they're going to simplify by different numbers. So I'll start, for example, over here on the right side. 15 and 10, I can divide both top and bottom by 5. If I simplify that fraction, 15 divided by 5 is 3. 10 divided by 5 is 2. So that's 3 over 2. If the other ones also give me 3 over 2, then we're good. That proportionality statement is a true statement. Take a look at 12 over 8. I can divide top and bottom by 4. I can simplify by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. So take a look. So far, so good. 3 over 2 is equal to 3 over 2. And let's simplify the very first fraction here. 9 over 6. I can divide top and bottom by 3. I can simplify by 3. 9, I actually should write it on the right-hand side, not 3 divided by 9. 9 divided by 3, 6 divided by 3. 9 divided by 3 is 3, 6 divided by 3 is 2. So take a look. With our proportionality statement, we were able to prove that, yes, all those sides are corresponding. They're all 3 over 2. So that is it. That is how you prove that two figures are similar. All right, let's go through and do the same thing for example number 2. Let's match all the corresponding sides and all the corresponding angles. So we'll start with AB. So AB is the first 2 letters. I'm going to compare that to the first 2 letters in the second polygon here. So HG. Don't forget the little line segment symbol up above. Let's keep it going. From B to C, it's the middle 2 letters. So I'm going to use the middle 2 letters, GF. Just a matching game, What about CD? CD, so the last 2 letters, that side from C to D would be corresponding to which one? FE. So from F to E. Put that line segment symbol up above. and then we got one more side, DA. So using the last and first letter, we're going to use the last E and H. So there we have it. So again, those are all the corresponding sides. Now let's go through and match up all of our angles, right? Let's go through and match up all of our angles. And it's pretty straightforward here. A, the first letter, matches up to H. So angle A is congruent to angle H. Let's continue to play this matching game. Angle B, second letter in the second part here is G. So angle B is congruent to angle G. What about angle C? If I take a look at my similarity statement, C is the third letter, F is the third letter. So angle C is congruent to angle F. And then, of course, the last one, right? Angle D is going to be congruent to angle E. So we just went through and we matched up all the corresponding sides and angles. All right, now let's go through and finish this. Prove that the figures are similar using a proportionality statement. So let's go through and match up all these sides. So we'll start here. AB, so from A to B, that was 6. I'm going to compare that to HG. So where's HG? HG was 9. So that's going to be 6/9. And you want to make sure that you stay consistent. See how I'm going from the small one to the bigger one? I want to make sure that I keep that order going. Let's move on to BC. Whoops. Side BC. Where is BC? BC here is 4. So we're going to match that up to GF. GF down here is 6. Continue to play this matching game. Move on to CD. So from C to D, that was 6. Compare that to FE. So from F to E, that was 9. So that's 6/9 again. And then we have one more side. I actually have to include one more fraction here, one more fraction. So let me bring down my equal sign, draw that division line. Let's go ahead and set up the last one here from D to A. So if the distance from D to A, which was 8, we're going to compare that to EH. E to H, that was 12. So that's our proportionality statement. Now I have to prove it by simplifying. I have to go through and simplify each one of these fractions and show that they are all actually equivalent. So what can I simplify 6 and 9 by? I can divide that by 3. So that would give me 2/3 is equal to, what can I divide 4 and 6 by? I can divide by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Keep that going. 6/9, well, I just did that earlier. That's going to be, again, 2/3. So far, 3 of these are all matching. 2/3 is equal to 2/3 is equal to 2/3. What about the last fraction when we simplify it? 8 and 12, I can simplify by 4. Divide top and bottom by 4. 8 divided by 4 is equal to 2. 12 divided by 4 is equal to 3. So take a look at that proportionality statement. I have 2/3 is equal to 2/3 is equal to 2/3 is equal to 2/3. Okay, so that is how we prove that, hey, these two polygons are actually similar. All right, example number 3. It says, are the following figures similar? Prove your answer, and if so, write a similarity statement. So our job is to go through the same process we just did here, right? Write a proportionality statement, go through. If our fractions are all the same, right? If all our fractions are all the same, then we know they are similar. If one of these was off, if I have 2/3 is equal to 2/3 is equal to 2/3, and then the last one was something like 2/4, then these would not be similar polygons. So let's go through and show this. Well, let me start by picking here this left side from P to Q. That is 24. I'm going to compare it over to the same side over here of the left one, of the smaller one, over 12. Okay, let's keep that going. We're going to set that equal to, let's keep picking another side. So I was working with the left triangle first. Let me keep working with that one first. So from P to R, that measures 48. Well, let's compare it to D to F, which is 24. All right, we're going to compare the last sides, the bottom sides here. So again, I was working with the bigger one first, so let's continue that. We have to be consistent. From Q to R, which is 16, We're going to compare that to the bottom side over here from E to F, which is 8. So there is our proportionality statement. Let's simplify to actually prove that these two figures are similar. I should be getting the same fractions when I go through and simplify. 24 over 12, I can simplify that by 12. Actually, I can divide 24 by 12. 24 divided by 12, right? 24 divided by 12 gives us 2, is equal to what's 48 divided by 24? That's also actually 2. And then what's 16 divided by 8? That's actually also 2. So this is true. These two figures are actually similar. These two figures are actually similar, right? Using our proportionality statement here, all these fractions are equivalent. So let's go through and write that similarity statement, okay? So if they are, if so, write a similarity statement. So we're going to say triangle, and I'll start here with P. I'll go down to R, and I'll come over here to Q. We're going to say that's similar, the little squiggly, to triangle. And again, the order does matter. So I started up here at angle P, so I'm going to start here at angle D, move down to R. R matches with F, so let's go to F. And then the last one was Q, which angle Q matches with angle E. So that is how we write our similarity statement. The order does matter. The order does matter. Let's try that one more time with example number 4. Are the following figures similar? Well, let's go through and compare. Let's match up these sides. If they are, we'll write that similarity statement. So let's begin. Be careful. These triangles are kind of flipped around. So take a look. I'll start from A to B. So from A to B, that was 7. Now be careful when you compare it to what side is it going to match up with. So there was 2 lines for angle A and then 1 line for angle B. So I'm going to do the same thing. There was 2 lines for angle Y. There's only 1 line for angle Z. So those are the corresponding sides, 7 to 14. Let's keep going, is equal to, I'm going to go ahead and match up from B to C. So from B to C, B had one angle symbol. Let me actually write 4 before I forget. Angle B had 1 angle symbol, which is angle Z here. And then angle C didn't have any angle symbols, so that is angle X. So we're going to compare that to 12. And then we have one more, which is, of course, the last one here from A to C, which is 6 over Y to X, which is 18. Okay, so take a look at our fractions here. So again, that is our similarity, our proportionality statement here. Let's go through and simplify. Well, 7 over 14, I can divide top and bottom by 7. That would give me 1 over 2. 7 divided by 7 is 1. 14 divided by 7 is 2. What about 4 over 12? I can simplify top and bottom by 4. Whoops. So what is 4 divided by 4? That's 1. But what is 12 divided by 4? I get 1/3. And take a look at the last one here, 6 over 18. We can divide top and bottom by 6. 6 divided by 6 is 1. But then 18 divided by 6 is 3. So is this a true statement? 1/2 equals 1/3 equals 1/3. That is not. So these figures are actually not similar. We're just going to say not similar. There's no way we can write a similarity statement. This was not a perfect dilation. Okay, this is not similar figures.